So this video is going to be all about my community training initiative plans, and it's all to do with having hands-on hardware that's cheap or free to be able to build training around. So here we see I've done a little emulator in LabVIEW, and all it is Visa and Scoopy is all he talks to, or talks to him, and he is emulating a Pico 24 Raspberry Pi board. So if I just start him running, he picks a subnet and we'll sit him on that subnet. If we then start Max up, we can have a look, and while Max is slowly coming to life, it's going to go quite quick today. Oh no, this will take ages. So it's just Visa. If we have a look at the code, it's just a TCP port listener, and then it just responds to the IDN and other commands for getting and setting hardware. In this case, it's a little multifunction board, so a few LEDs, a few buttons, some analog inputs, blah blah blah. Still going. So what we'll see here when he finally wakes up is that I can talk to him via his network devices and his OpenVisa panel. So it's just standard Ethernet. So this will work fine in a virtual machine as long as you bridge the Ethernet ports. So I just set him up, apply changes, boop, input and output, query him, and there he's come back with his. And you can see he's gone from connected to running. So connected essentially is listening. Running is he's got something connected to him, talking to him. But that's not really what we want to do. Apart from we want that reference set up. It's easy to set up. You just set up the socket number and the port number, and it finds it if it's there. So that's all nice. Visa's industry standard, Scoopy's industry standard, so it's a good skill and a good standard to teach people with, I think. Let's kill that. You see this has gone back to connecting now. But what we really want to be able to do is, here's an example, is from the palette build software for our examples. So here we got a standard sort of set of drivers, as you would get from the instrument driver building wizard thing. And you can see all this is doing is looking at outputs and setting inputs and all that kind of thing. Looking at inputs, setting outputs, that's probably more logical. So let's go. Essentially going around doing all that kind of stuff. Okay, so if we just run it to prove that I'm not lying to you. So you can see here, this will run, it will connect. If I set a piece of hardware here, you can see our lights come on over here. If I set 4, he sets there. If we want to have a look at some digital I/O, boop. Let's bring it over. See, that's going up and down. Very slow, very individual, very clunky. This could be, but that's only the command set, so you can have triggers and bring back data at fast and set data rates and all kinds of thing. So this is based on a Raspberry Pi Pico board, and I'm actually going to use a 2040 with a Ethernet port on it. So it's easy bit of hardware, $10. Plug in an Ethernet lead, and then you've got a piece of kit that you can talk to. And you've got lots of sort of training kit available to you. So that makes it very nice and easy. And if we stop here, this will go back to connecting and ready to listen again. So all very simple. And that's it really. So it's so all the hardware I think should be either emulated or free, emulated or cheap. So this comes even with these breadboards and the nice little widgets. It comes to about $30, which is well within what I think. You know, if you had 5 people and you charge them a ticket price, you can make that back. So it's something you can make money on doing this. Okay.